For my second topic and problem that I've picked out from the book, I chose chapter 8.5 on page 514. I chose number 21, and I'm just going to show how to go through what you had taught us on the test, how to do the hypothesis and statement, state the level of significance, A through F or whatever. And the problem is, in the journal Mental Retardation, an article reported the results of a peer tutoring program to help mildly mentally retarded children learn to read. In the experiment, the mildly retarded children were randomly divided into two groups. The experimental group received peer tutoring along with regular instruction, and the control group received regular instruction with no peer tutoring. There were N1 equals N2 equals 30 children in each group. The Gates-McGinty reading test was given to both groups before instruction began. For the experimental group, the mean score on the vocabulary portion of the test was 344.5, with sample deviation equaling 49.1. For the control group, the mean score on the same test was 354.2, with a sample standard deviation of 50.9. Use a 5% level of significance to test the hypothesis that there was no difference in the vocabulary scores of the two groups before the instruction began. Okay, so first what you want to do is write both hypothesis statements, and you want to state your level of significance. For the first one, you're going to have that they equal one another. Always, that's what you want to do. And then for the second one, since it says in the problem that there was no difference in the vocabulary scores, that's going to mean inequality. So then you would just make them not equal to one another. And then it states that you use a 5% level of significance. So that means that the level of significance is 0.05. Okay. And then next, you want to calculate the appropriate standardized test statistic. And in the book it shows you how to do longhand, but you taught us in the calculator. So what you want to do in the calculator, and I'll zoom into that in a second, but you want to use stat, then tests, then 2SAMP t-test, and then go to stats and put in all the data, and I'll have zoom into the calculator to do this. So I'm going to go to stats, tests, number 4, 2SAMP t-test, stats, and then I had already done this one already, but we're just going to re-put them in. It shows in the problem that x1 is 344.5, which is in there. For the first standard deviation, it was 49.1. Then it says that N1 is equal to N2 and that they both were 30, so that's 30, and then x2 it says 354.2. Then the second standard deviation was 50.9. Then, like I said, N1 and N2 are equal, so you want to do 30, and then as I said before, you want to make them not equal. Make sure that that option is selected, not pulled, and then you want to hit calculate, and it gives you everything. So this shows us that the t-value is negative 0.7512. So it's approximately negative 0.7512. And then we're going to sketch next. What you want to do, you want to sketch the distribution. So I'm just going to do a little sketch. You draw it up, and since this is the t-value, you want to put 0 in the middle, and then you're going to go to your positive 0.7512 and your negative 0.7512 and shade in each side. And that's what the sketch distribution would look like for this problem. And then next you want to find your p-value, which we did on the calculator. If you zoom into the calculator, you can see that the p-value is 0.4555. So I'm going to write that down. And then we make a decision. Number 5, we make a decision. We see that the p-value is larger than the level of significance, because the level of significance is 0.05. Because this number is bigger than 0.05, we fail to reject, and we say the data is not statistically significant. So fail to reject. And then lastly, you want to write a conclusion based on your decision. So you want to write out at the 5% level of significance. The evidence is insufficient to indicate there is a difference, and you want to use the word difference because it's not greater than or lower than, it's not equal, so there's a difference between the control and experimental groups, and the mean score on the vocab portion of the test. Because if we go back to the problem, we used a 5% level of significance. We showed that the p-score was bigger than that, so we reject it. There's insufficient evidence to show that there's a difference. It says there's no difference, to show that there's a difference in the vocabulary scores of the two groups. So that's just explaining that out. And that is how you go about doing that problem. And that is it.